The engineer's assessment regarding the electrical components near the paint spray booth is incorrect based on the National Electrical Code. NEC 516.3C4 clearly defines the classification of hazardous locations around enclosed spray booths and rooms. Specifically, it states that the space within 900 mm, approximately 3 feet, in all directions from any openings of an enclosed spray booth or room is considered a Class 1 Division 2 or Class 2 Division 2 hazardous location. The presence of a roll-up door does not negate this classification. The proximity of the electrical components housed in a NEMA 1 enclosure to the roll-up door places them within this hazardous area. NEMA 1 enclosures are designed for general-purpose indoor use to protect against limited amounts of falling dirt and dripping non-corrosive liquids. They do not provide the protection required for hazardous locations where flammable vapors or combustible dust may be present. Article 501 of the National Electrical Code provides detailed requirements for electrical installations in Class 1 hazardous locations. These requirements are designed to minimize the risk of ignition of flammable vapors or gases. Firstly, electrical equipment installed in Class 1 Division 2 locations must be suitable for the specific hazard involved. This typically means using equipment that is either explosion-proof or intrinsically safe. Secondly, wiring methods must also be appropriate for the hazardous location. Conduit and cable systems must be sealed to prevent the propagation of explosions or fires. Thirdly, proper bonding and grounding are essential to minimize the risk of static discharge, which could ignite flammable vapors. The statement that the engineer's letter is accepted as final word by the authority having jurisdiction does not override the fundamental safety requirements of the National Electrical Code. While a registered engineer can provide professional opinions and assessments, it is crucial that these opinions align with established safety standards and code requirements. The engineer's assertion that there is no problem due to the presence of a door is a misinterpretation of the code. The 3-foot radius extends from any opening, regardless of whether the opening is typically closed or open. The purpose of this requirement is to account for the potential for flammable vapors to escape from the booth, even when the door is closed. To ensure compliance with the National Electrical Code and maintain a safe working environment, the electrical components near the roll-up door must be relocated outside the hazardous area, or they must be replaced with equipment that is specifically designed and listed for use in Class 1 Division 2 locations. The existing NEMA 1 enclosure must be replaced with an enclosure that provides the necessary level of protection against the ingress of flammable vapors or combustible dusts. This typically means using an explosion-proof enclosure or a dust ignition-proof enclosure. In addition to the enclosure, the wiring methods must also be upgraded to meet the requirements of Article 501. This may involve replacing non-compliant wiring with rigid metal conduit or other approved wiring methods for hazardous locations. Furthermore, it is essential to ensure that all electrical equipment is properly bonded and grounded to minimize the risk of static discharge. This includes bonding the enclosure, the conduit system, and all electrical equipment to a common grounding point. A thorough review of the electrical installation by a qualified electrical engineer or inspector is recommended to ensure compliance with all applicable codes and standards. This review should include a detailed assessment of the hazardous area classification, the suitability of the electrical equipment, and the adequacy of the wiring methods and grounding system. It's important to consult the latest edition of the National Electrical Code for the most up-to-date requirements and interpretations. Code requirements may change over time, so it's essential to stay informed of any revisions or updates. In summary, the engineer's assessment is not consistent with the requirements of the National Electrical Code. The electrical components located near the roll-up door of the paint spray booth are in a hazardous location and must be installed in accordance with the requirements of Article 501. The NEMA 1 enclosure is not suitable for this location and must be replaced with an approved enclosure for hazardous locations. Compliance with these requirements is essential to ensure the safety of personnel and property. The NEC is very specific in these applications. Let us delve deeper into the specifics of Class 1 Division 2 locations and the requirements for electrical equipment installed in these areas. A Class 1 Division 2 location is defined as an area where flammable gases or vapors are present but are normally confined within closed containers or systems from which they can escape only in the event of accidental rupture or breakdown of such containers or systems, or in the event of abnormal operation of equipment. The key characteristic of a Division 2 location is that the flammable gases or vapors are not normally present in explosive concentrations. However, they may be present occasionally under abnormal conditions. Because of this potential for the presence of flammable gases or vapors, electrical equipment installed in Class 1 Division 2 locations must be designed to prevent ignition of these gases or vapors. The primary method for achieving this is to use equipment that is enclosed in an enclosure that is designed to contain an explosion. These enclosures are known as explosion-proof enclosures. Explosion-proof enclosures are designed to withstand an internal explosion without allowing the explosion to propagate to the surrounding atmosphere. They are typically constructed of heavy-duty materials, such as cast iron or steel, and they have tightly fitting covers with long, threaded joints. In addition to explosion-proof enclosures, other methods can be used to protect electrical equipment in Class 1 Division 2 locations. These methods include intrinsically safe equipment, purged and pressurized equipment, and non-incentive equipment. Intrinsically safe equipment is designed to limit the amount of energy available in the electrical circuit to a level that is too low to ignite flammable gases or vapors. This type of equipment is typically used in instrumentation and control circuits. Purged and pressurized equipment is enclosed in an enclosure that is continuously purged with a clean, inert gas, such as nitrogen. The positive pressure inside the enclosure prevents flammable gases or vapors from entering. Non-incentive equipment is designed so that it does not produce sparks or hot surfaces that could ignite flammable gases or vapors. This type of equipment is typically used in lighting fixtures and other equipment that does not contain arcing or sparking contacts. In addition to the requirements for electrical equipment, the National Electrical Code also specifies requirements for wiring methods in Class 1 Division 2 locations. Wiring methods must be designed to prevent the propagation of explosions or fires. The most common wiring method used in Class 1 Division 2 locations is rigid metal conduit. Rigid metal conduit is a heavy-duty metal conduit that is designed to withstand an internal explosion without allowing the explosion to propagate to the surrounding atmosphere. Other approved wiring methods for Class 1 Division 2 locations include electrical metallic tubing, intermediate metal conduit, and cable with a gas-tight continuous sheath. All wiring methods must be sealed at the point where they enter or leave an enclosure that is required to be explosion-proof. Seals are designed to prevent the passage of flammable gases or vapors through the conduit or cable. In addition to the requirements for electrical equipment and wiring methods, the National Electrical Code also specifies requirements for grounding in Class 1 Division 2 locations. Grounding is essential to minimize the risk of static discharge, which could ignite flammable gases or vapors. All electrical equipment and wiring systems must be properly grounded to a common grounding point. The grounding conductor must be sized in accordance with the National Electrical Code. The engineer's reliance on the door to mitigate the hazardous area is a critical misunderstanding of the NEC requirements. The code specifically addresses the area extending from openings, regardless of whether those openings are typically closed. This is because the potential for vapor escape always exists even with a closed door. The purpose of the hazardous location classification and the associated requirements is to provide a margin of safety to prevent explosions and fires. The AHA acceptance of the engineer's letter does not absolve the facility from its responsibility to comply with the NEC. The AHA role is to enforce the code, but the ultimate responsibility for safety rests with the owner and operator of the facility. If the AHA has accepted an incorrect interpretation of the code, it is important to bring this to their attention and to work with them to correct the situation. In some cases, it may be necessary to obtain a formal interpretation of the code from a qualified electrical engineer or code official. The installation of electrical equipment in hazardous locations is a complex and specialized area of electrical work. It is essential to have a thorough understanding of the National Electrical Code and other applicable standards. It is also important to use qualified electrical contractors and engineers who have experience in this type of work. Failure to comply with the requirements for electrical installations in hazardous locations can have serious consequences, including explosions, fires, injuries, and fatalities. Therefore, it is essential to take all necessary precautions to ensure the safety of personnel and property. Let's consider specific examples of equipment that would be appropriate for use in a Class 1 Division 2 location. For lighting fixtures, explosion-proof lighting fixtures would be required. These fixtures are designed with heavy-duty glass globes and robust enclosures to contain any potential explosion within the fixture itself. For motors, explosion-proof motors would be necessary. These motors are similarly designed to contain internal explosions and prevent them from propagating to the surrounding environment. For control panels and other electrical enclosures, explosion-proof enclosures would be used to house the electrical components. These enclosures would be made of materials like cast iron or aluminum and would have tight-fitting covers to prevent the escape of any sparks or flames. Wiring in these areas would need to be run in rigid metal conduit with explosion-proof fittings. This type of conduit provides a robust and sealed pathway for the wiring, preventing the escape of any sparks or flames. All connections and terminations would need to be made within explosion-proof junction boxes. These boxes are designed to contain any potential explosion within the box itself and prevent it from spreading to the surrounding area. Grounding and bonding are also critical in hazardous locations. All equipment and enclosures must be properly grounded and bonded to prevent the buildup of static electricity, which could create a spark and ignite any flammable vapors or gases that may be present. The use of non-incendiary devices is also an option in some cases. Non-incendiary devices are designed so that they do not produce sparks or hot surfaces that could ignite flammable vapors or gases. However, it is important to ensure that the specific device is approved for use in a Class 1 Division 2 location. The National Electrical Code provides detailed tables and guidelines for selecting the appropriate equipment and wiring methods for hazardous locations. It is essential to consult these tables and guidelines to ensure that the installation meets all applicable code requirements. Regular inspections and maintenance are also critical to ensure the continued safety of electrical equipment in hazardous locations. Inspections should be performed by qualified personnel who are familiar with the requirements of the National Electrical Code and other applicable standards. Maintenance should include regular cleaning, lubrication, and testing of equipment to ensure that it is functioning properly. Any damaged or worn equipment should be replaced immediately. In addition to the technical requirements, it is also important to consider the human factors involved in electrical safety in hazardous locations. Employees who work in these areas should be properly trained on the hazards involved and the procedures for working safely. They should also be provided with the appropriate personal protective equipment such as flame-resistant clothing and safety glasses. Clear and concise signage should be posted to warn employees of the hazards and to remind them of the safety procedures. Emergency procedures should be in place in case of an explosion or fire. These procedures should include evacuation plans, fire suppression systems, and first aid procedures. By following these technical requirements and human factors considerations, it is possible to minimize the risk of explosions and fires in hazardous locations and to protect the safety of personnel and property. The National Electrical Code is constantly evolving to keep pace with new technologies and changing conditions. It is essential to stay informed of the latest code requirements and to implement them in a timely manner. This includes attending training courses, reading industry publications, and consulting with qualified electrical engineers and inspectors. The goal of electrical safety in hazardous locations is to create a safe and reliable working environment for all employees. By working together, we can achieve this goal and prevent accidents from happening.